Welcome to my channel. In this video I will try to repair this digital timer. It's a socket timer. It has a model of Dedra and it has the maximum power delivered is 2300 watt, 10 amp and 250 volt. It has a tiny LCD screen. The problem is when we power in the timer, we see all the digits here. And it consumes 1.1 watt. I will open the case and we will see the problem. It has a long screw here. They are not the same length. They are different. This is a small one. And this one is so small also. So it must open now. This is a plastic case. Now we can find two boards here. This one for the timer, the circuit for timing, and this one for the power and the relay. It has 12 amp, 10 amp, 277 volt, they said. Now we can, it uses a capacitive dropper here. It has a capacitive dropper. Maybe this one is the Zener diode. I will investigate. We have some transistors here. Here we have the positive. Must be repaired before me. We have here the capacitor. So we have this one, the earth is flying. All are red. Not the earth. This one is the phase or the neutral. The life of the neutral. This is the earth. It must be connected directly here. Why they use this wire? This is the input and this is the output. They are connected to the relay, to this relay. So we have the neutral directly here, pass directly from this point to this point, and the life is connected via this relay. So here we have, for this input, we have in the input the capacitor. We have here the capacitor. This is the dropper resistance. No, this is to discharge the capacitor. It has 1 meg, 100 kilo ohm, or 1 meg. This for dropping green. If it's green, it's 1 meg. If it's yellow, it was 100K. we can see if we have some voltage here, we have nothing, so we can measure the resistance. We must find 1 meg here. Almost 1 mega ohm. So after the capacitor, we have here one resistor, two resistor. Here we have a battery. It was removed here. It's a battery to store the program. I will remove this blob, fix the wires. Here we have a Zener diode, maybe. Here we have a normal. Some diodes here. I will control those diodes. We have this one and this one. They have. I will test. This one is okay. And this one. We have the same. This one, the other position. It's okay. Now I will control the ZD1. This one is Zener and the other ZD2. We have two Zener diodes. This one may be a normal diode. I will control if it's okay. It's okay. We have here two Zener diodes. I will control them. This one is okay. I will reverse the polarity. It's okay. So maybe the battery, the problem with the battery, rechargeable. Maybe they use this battery to stabilize, to regulate the voltage. I will try to inject some voltage here, and we will see if the clock works normally or not. Maybe I will see if I have a rechargeable battery here. I will see if I have a small. Those all I have here. Maybe this one. They are nickel cadmium here. This one is no longer functional. I will try to solder this one, maybe for a fax, or I will measure first if we have some juice still there. I will cut the wires. I will cut and repair the cutter first. They are tiny wires with a small connector. I will see if we have here the plus and the we have no longer wires. Maybe it's corroded. Maybe we have some corrosion here. I will remove the plastic and see if it's okay, or I will search for another battery. Must be small. Here we can remove this plastic. We have here the positive, maybe. We have here two connectors for the battery. I will see if we have some inscription. It's corroded, it's no longer. I will see if we have some voltage. We have 0.7. We have no voltage here. I will see if I have another battery. Maybe here. This one is about to explode. All those batteries are nickel lithium batteries, so we can't use them. We must find the cadmium one. Maybe this one. Yes, it's a cadmium one, but maybe 3 volt. 3 volt. 3 volt. You can see here CR23. And CR. It's not 2351. I will maybe this one, maybe another battery. This one is rechargeable also. Lithium, this one is lithium. I will now measure this one. You can here see it has 3.2, so it's okay here. I can test where is the positive and the negative. Maybe this is a positive and this one is the negative. We have two holes here. There is a positive here and negative here. I will try to put the positive. This one is the positive. We will see if we can power this one is the negative, so I can do like this. This is the positive and this one is the negative. It's okay, but we have all the digits. You can see here. We have over voltage. See, when we release over 3 volt, when we release the battery, we can find that we have a normal battery, normal functioning. about 3 volt, maybe 1.5 volt, maybe 1.5 volt, not 3 volt, 1.5. Must find, so we must find 1.5 volt. Tiny battery. Rechargeable one. So here we can, this is 1.5 volt, and this one lithium there, not rechargeable. Maybe this one, it didn't put the voltage. I will try to measure the voltage for this one. It's a tiny connector here. Here we have 2.7, so it's a 3 volt rechargeable battery. Um, 1.5 volt. We can use one of those rechargeable nickel cadmium. They are nickel. They are not lithium, but nickel metal hydride battery. So they are safe if with electrical charging. If I can solder here the wires and put this battery inside, maybe it can do the job. One point 2.3, and this one 800, this one 120 milli 750 for the capacity. This one, maybe I will use this one, but first we must find a room here. Maybe we can sacrifice. After some tests, I found this is the best position for the battery, but I will sacrifice with this screw holder here. Before cutting this, I must test if it's okay or not. So I will now solder the wires to this tiny battery, rechargeable battery. I will now do some scratch here to get the solder fixed. I must found here red and black wire. Now I will put at least first some solder here. It's okay. On the positive one. It's okay. Now I put some ferrous solder to the connection here. This is the positive, and this is the negative. Now we will solder this. This is the battery wire, the lost wire. I must now solder this two wires to the PCB. I will shorten the wire. Here we can add at first some ferrous solder. I will use a short wire, but now this is only for testing. If everything is okay, now we must here found the positive. This is the positive one. We must add some fresh solder here. It's okay, soldered. Now we must solder the negative. We can test if the clock work or not. We have here, we can measure the voltage of 1.2. Maybe it work with 1.5. The maximum voltage here, which when it's charged, it's 1.4, I think, for those nickel cadmium battery or nickel metal hydro battery. From 1.2 to 1.4. I will solder the negative wire, but they are safe than lithium battery. They can be overcharged without explosion. Now it's soldered, the two wires are soldered. They are soldered. We see if there is any short circuit. It's okay. Now we must close the case without touching those wires. Can close the case. Ah, it worked now. We can see here that the timer work. Here we can select the program. You can see. Of course, the relay can't be active here. We need some power. Now I will put this in the main, and we will see if there is a problem. I will use this holder here. This one, because we can put this like this. Here we have in the off position, and we can put everything in the main. When we active, we can see here that it function, and we can hear the relay. We can hear the relay activated with the manual operation. So the problem may be solved. Now I will I will see how many voltage here we get in this battery. This battery now it's in main voltage. So we must be careful when we measure those voltage. We will find maybe 1.4 or 1.2 volt. 1.3. We can find now. It's now charging 1.3 volt. But with the earth, when we can test here, with the earth, here we have the earth connection. Can find here 27 volt and here 27. This is it's connected to the neutral maybe, not to the live, but still dangerous. 27 volt for between this connection and the earth. So now we must put we can now measure the voltage. I will shorten the leads to those wires, so I can cut here the positive or the negative wire and see how many amp it consumes. Maybe 10 milliamp or 30 milliamp. For trickle charging it's safe. We can trickle charge these batteries with a small current. If we can charge here the trickle charging, we can charge for the current. So here they say that the recommended rate for trickle charging is for nickel cadmium battery is C over 20 or over 200, between C over 20. Here we can find that we have the capacity of 800 milliamp. So we can do the calculation. 800 over 20, 40 milliamp. So if it's less than 40 milliamp, it's okay. Now we can here use the amp. Here on the amp, DC current. I will now use those here. This is the negative and this is the positive, and we will see how many current. Now it's okay. I will now put the timer in the socket, and now I will active. It consumes 2 milliamp. We have 2 milliamp. I will test the relay. The relay function. It function. It charge the battery with 2 milliamp. I will see if the LCD work fine. We have between 2 and 3 milliamp. So we have 800 over 2. After 400 hours it will be charged over 24 hours, 16 days. So after 16 days it will be fully charged. It's more than safe. I remove the protection and I assemble the timer. Now I will do a test with this charger. It's for nickel cadmium and nickel metal hydride battery. It can charge 4 batteries. I will plug the timer and plug this power supply. It's 12 volt power supply. Now I will power manually the charger. I must turn on the power, and now we can see that it functions. You can hear the fan. It has inside the fan here. Now I will stop the main. We can use. So the problem was with the battery inside. With this timer, they rely on the battery to stabilize, to regulate 1.5 volt for this little watch. I will use this timer and we will see if we have a problem with the battery or not. Maybe it will last longer than those tiny one. They has those batteries has a small capacity. Now we come to the end of this video. Thanks for watching and have a nice time.